So I was talking basically about the what are the challenges. See that means I told you that the fourth challenge is about the deep neural networks, which where number of hidden layers are there, but we don't know what is happening inside the hidden layers and so on. So last year, one of the basically project we got from the industry, like from Bangalore, project was basically displaying the results of intermediate results, which will really help, will be helpful to take the appropriate decision in future. So although ML has come very far away, we still don't know exactly how deep nets training is happening. So if we don't know how training nets actually happens, then how we can make the real progress. So visualizing the intermediate result is one of the important thing. Then another challenge, see that in a deep neural network and so on, currently we are basically training the neural networks for our together, like a number of epochs and so on, number of iterations going on, and then finally, or the database which is used very, very high, okay, rich data set or large amount of data set is used for training purpose. Now, question is that can basically our neural network will learn in a basically this way, in a single shot, one shot learning, a number of iterations will be reduced into a single iteration, and then automatically our neural network will work and so on. So this kind of neural network will really helpful to make the training faster. So traditional gradient-based network needs large amount of data to learn iteratively. So find the way to enable neural network to learn using just one or two examples, so which will reduce the time and memory also. Then people have not used this deep neural network for reinforced learning. So can we use this deep neural network for reinforced learning? That will be another area of research. Then semantic segmentation is also very useful for solving the real world problems. So that can be done with the help of deep neural network. So okay, one should think about it. So image classification is matured area. But now let's solve the semantic segmentation problem at semantic level, and this is possible with the deep neural network and so on. Another challenge, this is very important thing, is that nowadays whatever the training data which we are using, like for example we have 1 lakh samples which are used for training, those samples are in the form of one-dimensional, like as a speech samples are there, or biomedical samples are there, or image pattern samples are there. But nobody has tried to train the neural network on the videos. So can we use a video samples for training the deep neural network? And then, because you know that, simple thing that image speaks thousands of words, whereas video speaks thousands of sentences. So there is a rich information available in the video. So why not to use this rich information for training purpose and then make our neural network or deep neural network very effective. So utilize video training data instead of static images. That is also another area of research. So allow ML system to learn by listening and observing the dynamic world. Like for example, video for better result like as human being. And so machine should be able to do that one. Then object detection. So object detection is still hard for algorithms to correctly identify because image classification and localization in computer vision and machine learning are still lacking. So research efforts in this area are needed. Another thing, the last thing which I would like to talk about, see, when we are talking, utilizing so many AI applications or machine learning and so on, definitely, like for example, you have Google Assistant, or you have Apple Siri is there, or Amazon's Alexa is there. So where we can find immediately, we take the services of that one. And all those devices are there in your room. And definitely there is a threat for your security because the whole set of data will be recorded and it will be available at the company's side. You don't know how that will be utilized and so on. So what is the security for that? So that is the concern. Like privacy concern about the AI technology is one of the big issue. So in future, AI will dominate in our lives by incredible involvement or in the improvement in the healthcare or education or public safety. And because of the ability of AI tools to work quickly and accurately to collect and analyze the data, quantities of data, and then available of personal, huge personal data question arises how we can ensure our chances that, okay, the security and so chances are our private information may be used inappropriately or for commercial purpose also. So this is the reason basically okay, why people are hesitant to use this one. So address this question also. So there are basically futures of machine learning. Like for example, in future, machine learning can be used for finding the fine-tuned personalization. Like nowadays, we have a search algorithm, Google search algorithm is there, and so on. But the 90% of the recent data is generated from smart devices that connect our phones, wristwatches, and homes, and so on. So using ML, companies can fine-tune their target audience and to inform the product development and so on. So personalization can be done. Better search engines can be experienced by using AI technology, or even code-free this one evaluation of the data teams and so on. No code environment. See, your AI technology should be developed such that automatically it will write their own code in future. So no code environment will be there in the future, where AI will play a big role for writing their code as per situation or as per the problems. And then rise of quantum computing will increase the speed of hardware devices, which will make very fast the system to take the decision. So quantum technology or quantum computing will play a big role along with AI technology and so on. As I told you that AI retail. See, in future, all the shopping malls will be without any human being. Everywhere AI technology or robots will be used, and then record will be maintained, and services will be better, and so on. Healthcare also, it will be very, very smart healthcare in the future with help of AI technology. So more accurate healthcare systems will be available with AI, and so on. So for studying this subject, basically you need resources available. So there are several journals available. Like for example, IEEE transactional pattern analysis machine intelligence, where paper related to AI, ML will be available. IEEE transactional neural network, then IEEE transactional image processing, IEEE transactional multimedia, IEEE transactional medical imaging, Journal of Machine Learning and Research, or International Journal of Computer Vision, International Journal of Artificial Intelligence, pattern recognition, image vision and computing, or computer vision and image understanding, or pattern recognition letter, or ACM Computing Society. These are the top basically journals where research work is published. And there are conferences which are really important conferences, dominant conferences where good findings are reported. Like for example, IEEE CVPR conference, then ICCV, International Conference on Computer Vision, or European Conference on Computer Vision, ECCV, IEEE International Conference on Image Processing, that is ICIP, or IEEE International Conference on Pattern Recognition. These are the dominant conferences where the research work related to that is published, and so on. So this is all about my first talk. If you have any few questions, I can take it. After that, we'll have a break of 10 minutes, and then I will start my second session.
Yes, sir. Sir, this is Paithane madam. Thank you very much, sir, and sorry for inconvenience in between. Session was really very interested, as always yours, and with informative takeaway. So I have few questions with me. Can I proceed, sir?
Yes, please.
What will you suggest to start to expertise plan, means start to expertise plan for newcomers in AI?
See that I told you that. See, in AI, if you are newcomers and so on, I told you that AI is a big umbrella. Okay, under which you have to basically have the knowledge of image processing, you should have the knowledge of computer vision, you should have the knowledge of machine learning, you should have the knowledge of speech processing or natural language processing. They are statistical signal processing or statistical machine learning and so on. So this knowledge is very, very essential for giving a breakthrough in the AI. So I'll suggest you that you make a good study of all those subjects for newcomers.
Yes, sir. Thank you, sir. in line with this, sir, as maximum participants are from teaching fraternity also, how teaching faculty plan to make the students AI acquainted?
Okay, see, that's why I told you that even, okay, we have also changed our specialization. Okay. Earlier we were having PG, okay, only general MTech electronics. We started now MTech in artificial intelligence. So one thing I'll suggest you that, okay, when if it is possible for you people, make changes of your curriculum and then try to include all those subjects which are related to AI right from second year itself. Okay, then up to final year undergraduate also you can make one stream of students, those who are interested in AI. So for them at second year level you put a basic subject, and then third year first semester, second semester, so like that way up to final year. So tune your subjects curriculum in that way.
Yes, sir. Thank you, sir. One of the participants want to know that how AI is useful in counseling students for selecting their future study plan, or which type of algorithm we can go for this.
Okay. So this is just like as a for basically developing the expert system or AI expert system or emotion recognition, and then studying the previous interest of that student. Right now, okay, no algorithm is available, but definitely one can develop a new algorithm which will do the counseling of student. I gave one example here of AI, that AI can be used for hiring process. Now AI can be used for counseling process also. Okay, so but okay, presently no algorithm is available, and for that definitely you need a data of that student, particular data of that student. So once you feed that data of that student and then interactive session, so definitely AI technology will help that student for counseling or taking the career in future. Okay. But presently no algorithm is available.
Yes, sir. Thank you very much, sir. The one more question is how to decide to solve the problem using ML or DL?
Okay. See that there are simple things. Where you have, whether you are able or experts which are available to give you the features. Okay, so what kind of features can be extracted? So that information, if you know, then ML can be used. Okay, and then iterations will be less in that case, and then you'll get the quick result as compared to this one. So simple way is that if problem is well defined, in that case ML can be used. But if suppose, for example, if it is too complex, even expert doesn't know how it is happening and so on, but through number of samples, if you can learn, so in that case, basically deep learning algorithm where more number of samples are there and problem is bit difficult, in that case you go for this one, deep learning algorithm. Okay, but when the problems, like for example, okay, we have developed, like for example, diabetic retinopathy algorithms we have developed, or we have developed the survival prediction algorithm, where we got the expert opinion from the medical doctors, and they told that, okay, this is this one, this is this one, this should be okay. As a expert, we extract this kind of information, or we get this information, and then from that we make this kind of decision. So this is algorithmic kind of procedure which is available at the expert level. So that in that case you can use machine learning algorithm. But where the things are not clear, where things are complex, huge data set is available, huge samples are available, in that case I'll suggest you go for deep learning algorithm.
Yes, sir. Thank you, sir. I can see one more question, I think. How can a person use ML or DL for a person identification? Okay.
Yeah, same thing.
ML, DL.
Okay, whether it is a person or whether it is an object or whether it is a one-dimensional signal does not matter. Okay, I think I have given the this answer, previous answer.
Yes, sir. So we will end up this question answer session for this session. Thank you very much, sir. At what time the next session we are going to start?
Give me just 5-10 minutes for having a cup of tea, and then I'll join back. So it's already 12:05. So shall we start at 12:15?
Yes, sir. Yes, sir.
Okay,
Yes,
and
sir.
Okay, I'll request, okay, instead of ending at 1 o'clock, I'll end at 1:15.
Yes, sir. Yes, sir.
So
Okay, sir.
1:15 to
Okay.
1:15. Okay, we'll start. Thank you.
Okay. Thank you. Thank you very much, sir.
To disconnect it, I'll keep as it is. I'll go and have a cup of tea and then I'll come back.
Yes, sir. Thank you, sir. Thank you, sir.
Hello, good afternoon, participants. Your next session will start at sharp 12:15 p.m. So everyone please join at 12:15 p.m. or you can stay as login. Thank you.
Okay, so am I visibly?
Yes, sir. Yes, sir. Yes, sir.
And my this one presentation is visible?
Yes, sir.
Shall we start?
Sure, sir.
In the first session, I talked about AI and its application and research challenges. Now, in this session, I'll take one case study of how this AI can be used or machine learning can be used for solving the diabetic retinopathy. Okay. Now, see that during my PhD at IIT Kharagpur, I did work in the area of designing new wavelet. Okay, that wavelet was I have given a name of that wavelet as a rotated complex wavelet, and it has been published in Antimatter Injection. And after that, okay, another application. Okay, I use that wavelet for texture image retrieval, that is content-based image retrieval problem. And then application of that wavelet was also there to extract the rotation invariant texture features for content-based image retrieval. Okay, so that was my PhD work. But during 2010, okay, actually, I got postdoctoral opportunities, like 5-6 postdoctoral opportunities, but somehow I could not join all those means. First, I got first opportunity of postdoc at University of Barcelona, Spain, then University of Mary and Marie, France, Paris, then University of Glasgow, Scotland, then fourth one was IIIT Hyderabad, and fifth one was NUS Singapore during 2005 to 2010. But somehow I could not join that program. And then finally in 2010, when I applied for my postdoc at University of California under Boyce Fellowship, that is better opportunity for young scientists in children of science and technology, I got selected there for Boyce Fellowship. And then also I got a permission from my institute to carry out my postdoctoral research work at University of California. So during that time, I came across one of the paper. That paper was about survey of diabetic retinopathy or whole world. Okay, so this paper was basically written by a researcher whose name was Shahu. Okay, in 2010, and there basically he did a survey of 91 different countries all over the world, and he found that in 2010 there were 261 million people suffering with diabetes. Okay, diabetic retinopathy. Diabetes is different, okay, and the people who suffers with diabetic retinopathy is different. Okay. You know that there are two types of diabetes. One is a type 1 diabetes and another one is type 2 diabetes. In type 1 diabetes, okay, the people, those who suffer from very early stage of their life, and daily they have to take their insulin externally, so that comes under type 1. But with age related, like for example, after 40, 50 and something, people are suffering with diabetes, so that is type 2 diabetes. Okay. With both diabetes, basically, there is an effect of this diabetes on the retina or various parts of the organs of human body. Okay, and like, just 1 minute. These are the parts of the where people diabetes play a very vital role. Like people's eye, there is an effect on retina. Okay, there is an effect on kidney. There is an effect on your lungs. Okay, or there is an effect on your brain also, and so on. So there are several organs where basically people suffer with diabetes. Okay, and so on. And you might have seen that many people at the end they become blind when they are suffering with diabetic retinopathy and so on. What happens basically, you know that the eye of human being, if you see the structure of that eye, the structure of this eye is just like this. Okay. Front part of your eye is the small black circular dot, that is nothing but the pupil. Around that there is basically iris, circular. Some people have a black iris, some people have brown iris, some people have blue, green, and so on. Then behind that one there is a lens, and at the end of your eye, backside, there is a retina. So this part is basically a retina part. I hope that it is visible for you people. My cursor is visible. So this is whole retina. This is your lens, and then this is your basically pupil, and then around that pupil there is a this one iris. The role of pupil is basically to allow that how basically human being can see the whole world. The principle is that from the source, light get reflected from the object. See, from the source, basically light will fall on the object, and then object will reflect that light back, and then this light will be collected, the reflected rays will be collected through the pupil, and then they will enter in our eye, and then image is formed on the retina. Image is formed on the retina. So the role of pupil, small black dot, is to pass the amount of light, which reflected light, which will later on form the image on the retina. Now, how much light should be passed? This is decided by the retina. Decided by the pupil. Now you know that when you are reading in the dark room, you just expand your pupil. And when you are reading in a over lighted room, exposed room, then you have to basically compress that pupil. So the dilation or compression of the pupil is done by the iris. The role of iris is to dilate or compress the pupil. So amount of light which is entering through the pupil will be controlled by the iris. And behind that iris, there is a lens. You know that if you are a healthy person, then you don't need a spec. That is external lens. So the role of lens is basically form the image on the retina, exactly on the retina. Retina, but some people, in their eye, this lens does not work properly. So sometimes it may happen that image will be formed before retina, or it will be formed after retina. So to make this correction, external lens like specs are used, and then image will be formed on the retina. Now this retina, this part consists of several rods and cones. So number of cones are 6 to 7 million cones are there, which are responsible for sensation of color, and rods are responsible for sensation of the light intensity. You know that there are three types of cone. One is red cone, another one is blue cone, and third one is green cone. So it's not like as 33% cones are red cone, 33% cones are blue cone, and 33% are green cone. So total makes it 100% cones and so on. So research says that in our retina, though there are three types of cone, red cones, number of red cones are 65% cones are red cones, 33% cones are green cones, and only 2% cones are blue cones. And when a survey was carried out all over the world, which color generally people like most? In that survey, it was noted that many people like blue color most. But number of cones, blue cones are only 2% in our eye, human eye. Whereas red cones are 65%, green cones are 33%. And though RGB are the cones, red, green, and blue cones are there, but human vision system does not work on the principle of RGB color model. It works on the HSI color model, hue, saturation, and intensity. So, for a human vision system in the brain, our color model will be represented in HSI and so on. So this basically retina consists of several blood vessels and optic disc and macula area and so on. So because of blood vessel becomes weak and they start leaking blood on the retina. And if the leakage becomes more, then retina get damaged, and then that person start problem of vision. We'll see in our next slide where is the problem. So this is the problem of diabetes on the retina. And then at the end, you might have seen that, because in India, most of the people are suffering with diabetic retinopathy. As I told you, that survey was carried out, and then this whole world survey was carried out in 2010 of 91 different countries. Later on, many people carried out this survey, and at that time, 261 million people were suffering with diabetic retinopathy, and it was predicted by 2030 this figure will go up to 600 to 700 million people who will be suffering with diabetic retinopathy. And then see that in 2010, 261 million people, out of that 48 million people were residing in India, whereas means total 20% of the population of the whole world suffering with diabetic retinopathy resides in India. And it was predicted that by 2030, this figure will reach around 90 million people in India will be suffering with the diabetic retinopathy. Again, 20% of population of the whole world of diabetic retinopathy will reside in India. So these are the figures basically, worldwide figures. So it is expected that 55% increase will be there in South and Central America, 33% increase will be there in the North America, and then Africa 143% increase will be there, and then Middle East and North Africa 96% rise of diabetic retinopathy patient will be there. Southeast Asia 74% million people will be there. Western Pacific 31%, Europe 15%, and the whole world basically 51% people will increase with this diabetic retinopathy. And these charts, statistics shows basically diabetes affects the people of all ages, typically showing the higher prevalence with increasing age up to 60. Means basically this is more dominant in the older people as compared to the younger one, and so on. So another thing is that this statistic shows number of people with diabetes globally. And definitely India is the country where many people resides with diabetic retinopathy. Now, diabetes does not discriminate between the rich people and poor people. Diabetes can happen with anyone. But rich people can go to the good hospitals where screening can be done, and then they can take the preventive action, and then they can save their vision. But the poor people, those who are residing in the village area of India, they doesn't visit a hospital until and unless there is a severe threat. So apparently there are stages of diabetic retinopathy, like stage 0 to stage 5 as per international standard, and then if you are normal, it will be at stage 0. But some symptoms are there which happens at stage 1, then stage 2, and so on. Immediately your vision you will not lose your vision. But if you can contact to the doctor at stage 1 itself, then further loss of vision can be saved, and so on. So this will be possible if the facility is easily available to the people, easily accessible, and mass screening facility is available. So presently such systems are not available in India. So there is a need for developing a mass screening system which will screen the people at village level, and then they will be advised that you go and do take the further. See that diabetic retinopathy screening is not a treatment. It's basically a help for the doctors to screen the mass people and then advise these people to take the further treatment and so on, so that their further loss of vision can be saved. So this is the anatomy, this anatomy of your eye, and then this is the whole human eye cross section and so on. So diabetic retinopathy is a sight-threatening, chronic, and causes irreversible blindness. Once it happens, you cannot basically go back and have the new vision and so on. So it is better to cure at the right time. So screening of the people at the risk of DR or diabetic macular edema is crucial to prevent the irreversible vision loss. And in screening, most of the patients are normal. 80 to 90% of people are normal for DR and DME. Doctors spends a lot of time in rejecting the normal patients and so on. So there is a need basically to develop the technology which will help all those ophthalmologists to screen the patient at mass level, and only the patient, those who are suffering with diabetic retinopathy, will be referred to the ophthalmologist, and then they will not spend all those time to screening and so on, so they can directly give the treatment to those patients. So that's why there is a need for development of developing a diabetic retinopathy screening system, and this screening system means basically you have to identify what are the symptoms. Okay, you have to recognize it, and you have to predict at what level this person is suffering with diabetic retinopathy, whether it is at level 0 or level 1 or level 2 or level 4. There are 5 levels, 0 to 4. So that is the role of basically screening system. So computer-aided diagnosis provides an automated screening solution and helps to reduce the workload of the ophthalmologist. So there are several patients are there. As I told you that India is the country where 20% of the whole world population resides, those who are suffering with diabetic retinopathy. So we really need a large screening system which can be done automatically and so on. So this is basically a person screening system will do. Take the picture of that retina of the human being, and then you need to develop the algorithms. See that the person who is suffering with diabetic retinopathy, as I told you that his blood vessels of retina becomes weak, and because of that, it starts leaking blood on the retina. Okay. Now retina, see that. See that. Just 1 minute. Let me show you. Retina. See, this is the color fundus image of the retina. You see left side's image. The right side is the camera, through which you can capture the fundus images of retina. Okay. Now see that there is an optic disc. Okay, it is shown on the left side figure, optic disc, and then beside this optic disc, you can see there are several nerve fibers are there, and then foeva region is there. Foeva region is very, very important in diabetic retinopathy. See, and also you will see there are several blood vessels in this fundus image or retinopathy image, fundus image. And because of diabetes, these blood vessels become weak and they start leaking blood, or the lipid profile, white dots will be there on the retina, or red dots will be there. So when blood is in a small amount, the small red dots will be appearing on the retinal image, and that is called as the microaneurysm. If it is in large size, then it is called as the hemorrhages. Similarly, the fat kind of things, if it is deposited on the retina, then it is called as basically exudate, hard exudate and soft exudate. I'll show you all those images. Where is the soft exudate, where is the hard exudate, and so on. So if all those things deposited or basically appeared in the near foeva region, then there is a threat that person will become blind. But if it happens outside, then the chances are very, very less, and so on. So here, let me go back. So screening of, okay, identifying the all those symptoms, like whether there is a hemorrhages, how many hemorrhages are there, how many microorganisms are there, how many soft X-rays are there, how many hard X-rays are there, is there any neovascularization, is there any detachment of the retina, and so on. So this can, okay, you need to basically develop an algorithm by using image processing, computer vision, and machine learning, okay, to detect all those things, and then automatically it will detect when you are capture the retinal image. It will be analysis will be done, and then based on that analysis, a recommendation will be given that this person is suffering with level 1 or level 2 or level 3, or it is at last stage level 4, and so on. So this can be done automatically with the help of AI technology. Now see that here, the person who is normal, how that person can see the whole world. So left side person is having a normal vision, and the right side image basically here is the person with diabetic retinopathy. The same scene seen by a normal person will look like as the left image, and the person who is suffering with diabetic retinopathy will see the world okay, which is shown in the right image. So detection of disease in early stage may allow the patient to undergo the treatment to avoid the vision loss. So diabetic patients are suggested to do the regular biannual or annual checkup of their retina, but this retina screening is costly, okay, because you know that the retinal image, can we capture the retinal image with the help of this camera, simple camera? No, because see that simple camera will capture the beautiful pictures of human being, okay, and the range of wavelength of this camera is from 400 nanometer to 700 nanometer. You know that. Can we capture the picture of the human being with the help of, okay, X-ray images of the human being with the help of this camera? No, because X-ray wavelength is different than the camera which is working on the for normal picture. For normal picture, the wavelength of this camera is from 400 nanometer to 700 nanometer. X-ray imaging is different. PET imaging is different. Okay, so all those every camera is designed for particular wavelength. Okay, so retinal camera, okay, we cannot capture the retinal fundus images. We need a separate camera, and the cost of that camera, see here, in our center of excellence, we purchased a very low resolution camera. It was costing in 2011-12. We purchased that one. No, not 2011. It was 2014-15. Okay, we purchased that fundus camera. It is called as the fundus camera, and it was costing around 11.5 lakh rupees. High resolution fundus camera cost around 1 crores and so on. And if ophthalmologist is having high resolution fundus cameras, so and they have invested that much memory, so definitely that much money for creating the infrastructure, definitely they will demand very high fees from the patients. And for paying such high fees for the poor people is very, very difficult. Okay, and then they avoid for going to the ophthalmologist and so on. So, but the loss is with patient, because okay, if they don't take the treatment at the right time, then there are chances that their vision will be lost. So though it is suggested that the person who is suffering with diabetic, they should check their vision at least once in a year or once in a 2 year and so on. So that is nothing but the screening. So see, this is this figure, like against the national ophthalmologist. What is the population of how many ophthalmologists are available in India? The population ratio of 1:1,07,000. Okay, there are various regions in India which have the ratio of 1:9,000, but there are some regions where you will find the ophthalmologist, okay, 1 in 1,07,000, 1 in 9,000, and so on. So, okay, treating those huge population for ophthalmologist for screening is very, very difficult. So we need a technology which will support those ophthalmologists. Okay, so to manage such a huge population, large-scale screening programs are very, very essential, and technology should be developed accordingly. Now, in what way images are captured in case of fundus? Retinal images. So we can capture the retinal fundus images by using color fundus photography or scanning, laser ophthalmology, or optical coherence tomography. See that, suppose for example, if somebody's retina is swelled, now with the help of simple fundus camera, can you find the swelling or so on? No, it is not possible. You need a three-dimensional imaging in that case, and three-dimensional imaging with the fundus imaging is not possible. So you get only two-dimensional view. Okay, so here you need optical coherence tomography in that. Okay, 3D optical coherence tomography, so that you can get the slices of your retina, and then from those slices you can predict whether that retina is in normal condition or it is swelled at particular location or so on. So if it is swelled, then you can refer to the treatment for the other treatment. But with simple fundus camera, it is not possible to get the 3D structure and so on. Another way is to obtain the fluorescence angiography, then endosign green angiography, or wide field ultra wide field retinal imaging. Means in retinal images, obtaining retinal images, there are several technologies available nowadays. Okay, so this is basically a simple fundus camera, right side, and then the image which is shown here is the color fundus image displaying the optic disc, foeva, retinal blood vessels with arterioles and venables, that is darker, and white optic nerves and so on. This is another camera with which you can obtain the retinal images. So that is nothing but the scanning laser ophthalmology, ophthalmoscopy. So with this camera, you can get the this one fundus images like this. Then, as I told you that we need a 3D structure for seeing or visualizing whether that retina is swelled or not. So for that, optical coherence tomography, 3D optical coherence tomography, where you get the cross-sectional view of your retina, and then you can visualize the entire retina internally. And then, so this is the retinal imaging technique of these cross-sectional views of retina. Then another technique for obtaining the retinal image is fluorescing angiography. Okay, so this is one of the technique also for obtaining this one. Then endosign green angiography is also next technique where we can obtain the images, or wide field and ultra wide field retinal imaging is also possible to obtain the retinal images. Okay. Where now see that, as I told you that when the person is suffering with diabetic retinopathy, how many symptoms are there in the retina? So there are near about 10 to 12 different symptoms are there, like for example, macroaneurysm. Macroaneurysm, you see that here I have shown a small red dot is called as the macroaneurysm. This is expanded version of that one. Okay. Then this one, the large red dots are called as the hemorrhages. See that this is the expanded version of this one. This is the optic disc. Okay, and you know that these are the white dots. These white dots are called as basically a hard exudate, where you'll find that in these white dots the boundaries are very clear, but this is also one more white dot where boundaries are not very clear. So this is called as the soft exudate. This is soft exudate, this is hard exudate, this is macroaneurysm, this is hemorrhages. So these are basically the symptoms of person who is suffering with diabetic retinopathy. So macroaneurysm, hemorrhages, then exudate, that is hard exudate, which we call. This cotton spot, that is nothing but the soft exudate. Then neovascularization. Neovascularization, see that here you will find that there are, if your blood vessel of retina is weak, then there is a tendency of human visual system that it generates a lot of blood vessels near to that blood vessel. So lot many blood vessels are called as generation of lot many blood vessels are called as the neovascularization problem. Okay, so generation of extra blood vessels in that case. Okay, so that is nothing but this one, neovascularization. Then retinal detachment. If some person is suffering with a last stage of diabetic retinopathy, then that person's retina starts getting detached. And if that detachment comes to near foeva region, that person will become blind at that time. okay, or vitreous hemorrhages. A lot of blood is accumulated in the retina, so that is nothing but the vitreous hemorrhages or venous abnormalities. Okay, not many blood vessels are generated. See that microaneurysm, as I told you that microaneurysms are the name. So a small circular chain that involves capillaries of many vascular districts such as heart, kidney, and eye. And basically, it is a small red dot which is there on the retina. So that is called as the microaneurysm. The second one is hemorrhages. Here I have shown in this image. All those red dots, but large in size. Sometimes it may be in the size of flame or like that. So that is called as the hemorrhages. Then exudate. As I told you that exudate is its color is a whitish color is there. But you will come to know that, see that this is the optic disc. Its color is also whitish, and this is the hard exudate, which color is also whitish. So sometimes this hard exudate gets confused with the when you are detecting, when you are developing the system, developing system for detection of the hard disk, hard exudate. At that time, your algorithm may get confused with the optic disc also. So it is suggested, always suggested, that whenever you develop any algorithm for detection of microaneurysm or hemorrhages or hard exudate or soft exudate, first thing is that you have to remove the optic disc. Means you need a first algorithm for detection of the optic disc to remove that. Second thing is that you need an algorithm to detect all blood vessels. Now, when you remove optic disc and all blood vessels, the remaining portion or remaining things which will be there in the retinal image will be all those symptoms. And after that, you can detect how many hard exudates are there, how many soft exudates are there, how many macroaneurysms are there, how many hemorrhages are there. So, soft, basically hard exudate is whitish in color and it has sharp boundaries. You can see in this image this soft exudate there. And then cotton wool spot, that is called as the soft exudate. But here, as compared to the hard exudate, there in hard exudate you will find in ring-in form, or they are basically having sharp boundaries. But here in soft exudate, you will not find the boundaries are very sharp like as a hard exudate. Colors are same, but the boundaries are different. Then neovascularization, as I told you that in diabetic retinopathy, one of the feature is neovascularization. Means, see that near the optic disc, lot many, see here this is the optic disc, and lot many blood vessels are generated because these blood vessels, the main blood vessels are becoming big, and then a lot many blood vessels are generated. So this is also one of the sign of diabetic retinopathy. So generation of extra blood vessels is called as a neovascularization. So you can detect that as one of the feature of diabetic retinopathy. Then I told you that if person is suffering with diabetic retinopathy since long, at the end his retina starts getting detached. See that retinal tear will be there here, and then this retinal tear, this retina start getting detachment, and if that detachment comes near the foveal region, you will lose your vision. So that is very dangerous case. Another symptom of diabetic retinopathy is this one, vitreous hemorrhages. See, a lot of blood is accumulated in the retina, and then if that is happening in the foveal region or macular region, then that person will not be able to see the things. So this is also a diabetic retinopathy symptom. Now we'll see that here, normal retina and diabetic retinopathy retina. In normal retina, you will not find any kind of microaneurysm or hemorrhages or soft exudate or hard exudate or neovascularization or retinal detachment. All those symptoms are absent. So top left figure shows the normal retina, where you will find only the optic disc very clear, then blood vessels are there, and then you will find the foveal region or macular region to the left side of optic disc. So this is very important central portion of the vision system. And then the person who is suffering with diabetic retinopathy may have the symptoms of microaneurysm, may have the symptoms of hemorrhages, may have the symptoms of hard exudate, soft exudate, or neovascularization. So the right figure of first row shows the diabetic retinopathy. Then DMA, okay, diabetic macular edema, the person who is suffering with, okay, normal person is very clear. But the person who is suffering with, okay, macular edema will have the hard X-ray symptoms, or venous bleeding will be there, cotton wool spool will be there, hemorrhages will be there, and so on. Okay. So as I told you that as per the international standard, in the case of diabetic retinopathy grading, there are basically 4 stages. One is a 0 stage, level 0, level 1, level 2, level 3, and level 4. So level 0 means normal, and then severity will increase with all those levels. Okay. Now, basically, I'll tell you that what we have done. My research, okay, see, during my postdoc also, I worked on diabetic retinopathy problem for detection, okay, detection of optic is the removal of this one, blood vessels, and then the detection of microorganism, detection of this one, hemorrhages or hard X-ray, and so on. After coming back, okay, my researchers, near about 4 to 5 research scholars have done work on the diabetic retinopathy, and this work is basically first thing is that, see, as I told you that the database which is available earlier when I was doing my postdoc, at that time limited data was available, and mainly those databases were from France, that is Messier database, or US direct database was available, and then HEI database was available. But the number of samples was very, very limited. Like as in direct database, there were only 89 samples were there, whereas in case of this one, Messier database, which was the largest database available, it was having 1200 images and so on. But there was no single database. See, as I told you that in literature also, it is said that more number of people from India, they are suffering with diabetic retinopathy, but database available is very, very less, or basically no database was available from Indian population. So my postdoc supervisor suggested me that after going back to India, first thing you do is that create the database of Indian population, which will be really useful for the doing research in this domain and so on. So fortunately, after coming back, when I came back on 16 September 2012, I was given the responsibility for establishing the Center of Excellence. So I prepared a proposal and then submitted that proposal to the government of India for establishing the Center of Excellence. And then fortunately, there were 200 proposals all over India. And then they shortlisted 30 best proposals. And my proposal was one among them, and finally we got 5 crores funding for establishing the Center of Excellence. So under that, we established in 2013-14 year, 14-15 year, we established the state-of-art Center of Excellence in signal image processing, where a research related to signal processing, image processing, computer vision, machine learning is carried out, and 35 full-time research scholars are working in that domain. And mainly we are focusing on the medical field, like as a diabetic retinopathy, then cancer detection, like as a brain tumor detection or lung cancer detection, and so on, and knee imaging. So we have a group, basically a strong group of 19 faculty members, those who are working in this area. And also we started recruiting the full-time research scholars and so on. So fortunately, I got very good research scholars working with me, and then and also we got a support from the local doctors. See that getting a success in biomedical field depends upon how much support you get it from the doctors. Because as an engineer, we may be very good in developing the algorithm or new technology, but we don't know the medical terms. See, whatever the terms which I have referred like as a microorganism or hemorrhages or soft X-ray, hard X-ray, and so on. So for the person who is listening first time, you'll find difficult. Okay, so engineers will find all those terms difficult. unless and until it is told by the doctor what is meaning of this mechanism, okay, where it should be there and how to identify it and so on. So fortunately, we got a support of local doctors like Dr. Girish Deshmukh from Nanded and also Dr. Sastra Budde from Government Medical Hospital. And then we started collecting the database of Indian population, and we created the first database which we call as a IDRID, that is Indian Diabetic Image Retinopathy Data Set. So that is the name which we have given. And then once that data set is created, see, only collecting the image is not creation of the data set. You have to create the ground truth of all those. So ground truth means basically which pixel of this diabetic retinopathy fundus image belongs to mechanism, which pixel belongs to hemorrhages, which pixel belongs to this one soft X-ray, which pixel belongs to hard X-ray. So all those information, basically, we got the help of doctors. So doctor came to our center of excellence. They were working with our research scholars and then making the ground truth of every image. And we created the first Indian diabetic retinopathy database. And then in 2018, we submitted a proposal to launch this database at international level. And then we got a support from University of Texas, USA, then University of Burgundy, France, and then UTB, Malaysia, and then University of Edinburgh, UK. So these four partners were with us and our college institute, and then our proposal was accepted as for conducting the interaction challenge in ISB, that is Interaction Symposium on Interaction Symposium. So this interaction challenge on diabetic retinopathy, myself and my 3 research scholars, we went there and then we conducted that challenge. And then after that, this database was made available to the public. And nowadays, more than 64 countries are using our database. And many industries are also interested in this database because this is the representation of Indian population in the database. After that, again we created another database with 30 more symptoms. So this database now this year got accepted in again ISB 2021, which will be held at France in April 2021. So we'll be conducting another challenge in April 2021. Don't know whether it will be physical or online. Depends upon the pandemic situation, but mostly it will be online challenge. We'll be conducting that challenge from India only, but this will be under this. So under me, 4 or 5 research scholars work in the diabetic retinopathy today. Other research scholars work on other different domain of image processing and computer vision and so on. And researchers at our center have developed several algorithms for optic disc detection, several algorithms for macula detection, then cup to disc detection, ratio detection, and also for detection of mechanism, detection of hemorrhages, detection of exudate, and so on. So that work is carried out. I'll just give you the glimpse of that one, all those work, what we have carried out. So this is all those earlier work. So these are the different data sets which are available. Okay. And IDRID is the first database which I have shown here, is the Indian database which we have created. And and then other databases are also available, but this is the larger database. So IDRID, you will find this database website is given on the screen, idrid.grandchallenge.org, and this website for you will get this one. So all those are retinal challenges. Website is there, and result. There are standard ways for evaluating the results. So which we have used by finding the true positive, true negative, false positive, and false negative, and then sensitivity and specificity is measured, and also accuracy is also measured from the true positive, true negative, and false positive, false negative, and so on. And also precision and F1 score is also used. And so these are the basically measures which are used for the success of retinal screening and so on. Also, Jacquard distance is used for optic disc detection. Okay, so how accurate your algorithm is detecting optics for that Jacka distance is used. So new image database. Now this, see that when we conducted a diabetic this online challenge at ISB, okay, participants from 55 different countries participated in that one, and then we did a level 1 this one challenge at India only, and after that we selected only 16 top performing this one teams, and then we invited all those teams at USA, because that was the place where challenge was supposed to conduct, final challenge was supposed to conduct, and then okay, these 16 teams participated there online, and we gave the problem, and then we evaluated that result, and finally, okay, the winners were declared and so on. And then after that, we wrote a paper on this IDRD, Diabetic Retinopathy Screening, Segmentation and Challenge. Now this paper is, okay, a very big paper, and it has been published in the Journal of Medical Image Analysis, whose impact factor is 11.11. That is 11.11, very high impact factor, even more than IEEE transaction. See, I published a paper in IEEE transaction of system analysis whose impact factor is 6 point something. Okay, or PAMI is also having an impact factor around 8. But this medical image analysis, this journal is having an impact factor of 11.11, and number of authors here are 57 authors are there for this paper. So my research scholar, Mr. Prasanna, Samiksha, myself, and then Ravi, all those are okay involved in this. And this is the, you'll find this paper in medical image analysis. Okay, last year only this has been published. Then before that also we published a paper on India Diabetic Retinopathy Image Dataset, RDRID, a database of diabetic screening system in a data journal. Okay, journal name is Data, MPRI. Okay. So this is basically okay, we created the database, every pixel at pixel level as well as at image level. We marked the did the image annotation. So in this way, image annotation was done with the help of local doctors, and then ground truth was created like this image. Okay, ground truth was created, and then disease grading, okay, for POEVA detection and this one optic detection. This was the first challenge, because in one challenge there were 3 parts. One part was detection of optic disc, another one, okay, and POEVA. And then we have compared our database with existing. See that the last row shows that our IDRID database, okay, has a very, okay, all those possibilities, means optic disc, ground truth is available, then POEVA is also available, and then this one, macroism, and then hemorrhages, exudate, hard exudate, soft exudate, and then field of view, and then non-Diabetic camera, and then all those, okay, number of experts are also more. So our database is basically full-fledged database which is available. Okay. So just 1 minute. So this was, and then so challenge workflow was like this. Okay, we created the database. Then after that, data annotation was done. Then okay, data preparation was carried out. Then registration was done. Then we provided the training set. Then okay, algorithm development was done. Then test set was okay given, and then paper submission was called. And after that, on-site challenge was this one. Done and so on. So then okay, so that was one part. Then retinal disease screening also there. Okay, retinal image analysis for disease screening through local tetra patterns. We have developed a new method. So my research scholar Prasanna and Samiksha, they have developed that method of this one. Retinal image analysis for disease screening through local tetra patterns. Okay, so you will find the paper here, this one. Again, computers in biology and medicine, a recent paper in this area. Then, okay, so this is the workflow of this paper. Then final testing, definitely our result was better as compared to the earlier one. And second work which we have developed is vessel segmentation. So vessel segmentation, see that another thing is that not only diabetic retinopathy, but you can predict whether that person will be suffering with a stroke in future from the blood vessels of this one retina. So you can find the vessel blood width, vessel width, and then from that, research is carried out nowadays whether that person will be suffering with a heart attack or like that in future. So that can be also done with the help of this retinal image analysis and so on. So vessel segmentation is also, we have done the work. So this work, a novel unsupervised framework for retinal vasculature segmentation. This paper is also published. And then see that we got a very good result of blood vessel segmentation. And then also vessel width, also we can measure blood vessel width. So algorithm is given in that paper. You'll find that one. And then was vessel diameter measurement. So that is what I told you, that vessel diameter measurement is a new research in this field where which will be used for predicting whether that person will suffer in future. That person, chances are that person may suffer with a heart attack or a brain stroke and so on. So that kind of things can be predicted with the blood vessels measurement and so on. Then, so these are the challenge. So vessel segmentation, automatic blood vessel extraction technique using fixed stage transform in retinal image. This is done by one of my research scholar, Ravi Kamble. And then you'll find all those details in our paper. So these results are there. Then optic disc and POA localization. This work is also carried out. This work is published in Computers in Biology and Medicine. So localization of optic disc and POA in retinal images using intensity-based line scanning analysis. This is very simple technique, very effective technique he has proposed. And this work is published in elsewhere publication in Computers in Biology. So simple, what he has done, he has just scanned the image, and then where you have this one optic disc and POA region, the changes are very large in that case, and then you can detect very easily and accurately. So that is what he has done by scanning this one disc intensity profile of this one, and you see that scanning is done, and at the location of optic disc and POA, you can detect very accurately, and the accuracy is very, very high, and then speed is also very high in that case. Then optic disc segmentation is another work which is carried out by my other research scholar Samiksha and Prasanna, by extending this work. And then POA segmentation is the method which is proposed by Samiksha, a novel method for detecting POA from the color fundus images. So region of interest and so on. So this is the algorithm. And then DR detection. This is proposed DR diagnosis using bag of visual words. So this work is done by Prasanna, and this paper is also published in a very good journal. Then lesion segmentation. So detection of microorganism using the local rank transform of color image fundus images. This work is done by Ravi Kamble. And also detection of bright and dark lesion from the color fundus images using delta rank transform done by Ravi. And we have also collaboration with UTB Malaysia. So these are the works you'll find. And then lesion segmentation is also another work which is carried out by research scholars. Then detection of DR and DME by using deep learning algorithm. We have developed a method by using deep learning algorithm, and BCC16 is used for that one. And this work is also published in a good journal. And then detection of DME, this is done by Ravi, and we have a collaborator from Pune University also. So by other, you'll find that other co-authors are from Henning Müller, he is from Switzerland, then Fabrice is from France, then Gonzalez is also from Switzerland, and then CY Chan is from UTP Malaysia. So we have international collaboration in this area and did good work in this area. OCT imaging also, we did some work in that OCT imaging. So these are the references. Okay. And so I have given a bird eye view in which you can work, or what kind of work we have developed and done and so on. So if you have any question on this one, we'll be happy to answer the question.
Yes, sir. Thank you, sir. Am I audible, sir?
Yeah.
Yes. So I have a few questions. Can we proceed, sir?
Yes.
Hello. Yes, sir. In session, actually, you have discussed about the retinal data sets developed by your group. So in biomedical database, authentication is a very sensitive issue. So how to proceed in this direction?
See that, as I told you that getting success in the work of biomedical field depends upon how much support you get it from a medical expert. Like for example, we are working in the diabetic retinopathy, so definitely we need a help from ophthalmologist. My other group is working in brain tumor segmentation, so they need a help from the doctors those who are working in this one. So, and not only one doctor. See that we need at least 3 to 4 doctors for creating the ground truth, because some doctors some doctor may have opinion, no, this pixel is of this region, this pixel is of this region, and so on. Other may say, no, this is not like that. Then there will be confusion. So if majority of people say that this is this one, then we can mark that. We can create a ground truth and so on. So my suggestion is that those who are want to work in this field, first thing is that they should identify the support of the medical expert in this field, and at least 3 to 2, more than 2 people should be there to support you, to give the guidance in this field. Because we are engineers, we don't know the terms of medical field, and developing the application in medical field really requires the great help from the doctors.
Yes, sir. Thank you, sir. So in this regard, can you suggest a few names that labs or any organization that are providing this type of database which are already authenticated?
That is what actually, we created our own database because we have a this one fundus camera which we purchased, and also our local doctor is very generous. He was more interested in research, so he has also collected thousands of images, so he also shared that one. So my suggestion is that, or even for cancer, you know that in India there is a very good hospital, Tata Memorial Hospital. So if you can establish a connection in Tata Memorial Hospital, because these doctors are really busy, and then we could establish the connection. We had a MOU with Tata Memorial Hospital, and we got basically a database from the database by Tata Memorial Hospital. So there are several hospitals available. You need to tap that opportunity and go and talk with the doctors. Maybe one time it's not possible, you have to go again and again, and then find the ways, and means to get the database, and also the technical support, means basically medical support on their side. Yeah.
Yes, sir. Thank you, sir. One of the participants want to know which wavelet features we can use for texture classification.
See that basically wavelet gives the information of the images. See, in wavelet itself there are several wavelets available. See that more than 250 wavelets are available. Like for example, standard wavelet is there, M-band wavelet is there, Poisson modulated wavelet is there, then Gabor wavelet is there, then this one rotated wavelet, rotated complex wavelet, ridgelet, curlet, beyond wavelet. So like that way, more than 250 wavelets are available. Okay, if you consider the standard wavelet, standard wavelet gives information in horizontal direction, vertical direction, and diagonal direction. Whereas in Gabor wavelet, you'll get the information in all the directions. See, it depends upon how many directions you select, and definitely when you are recognizing any object, if you get more directional information, the strong set of feature you will get. So I'll suggest that If your object recognition is of multiple direction, then Gabor wavelet will be the best. Only thing is that Gabor wavelet have a problem of high computation complexity, and requirement of memory is also very high. Otherwise, you can also think of the combination of this one, complex wavelet and rotated complex wavelet, because complex wavelet will give you the 6-direction information, rotated complex will give you the another 6-direction information. So if you combine that one, you'll get the 12-directional information of the whole object. And extracting the information in 12 different directions will give you more strong set of feature, and accuracy will be very high. And you know that this complex wavelet or rotated complex wavelet is having computation complexity less as compared to the Gabor wavelet. Okay. So you can think of that.
Yes, sir. Yes, thank you very much, sir. So with the, actually we have few questions already answered in the session, so I will not take this. So with this, we are at the question answer session end, sir. So I, Dr. Sakshi Paithane, take this opportunity to propose vote of thanks to Dr. Manesh Kokare, sir, for accepting the invitation for this FDP. Thank you very much, sir. Sessions are really very interesting and informative as always, delivered by you, sir. You have explored AI information sphere, covering all possible aspects related to AI, and in the next session also. Thank you very much, sir. Thank you, sir.
So shall I close now? Shall I leave the meeting?
Yes, sir. Yes, sir. Yes, sir. Sure, sir.
Hello, good afternoon, ma'am. Hello, Vichikar,
Yes, sir. Yes, sir. Yes, sir. Please give the
shall we
next
start now?
instructions, sir.
Hello.
Hello, हाँ, sir.
Okay. So we'll meet at. So all participants, I request you, we'll meet at 2 p.m. Okay. Thank you.